Namaste, welcome back to Stitha Pragna, and you are watching AWS real-time projects for beginners to expert playlist. And so far we have finished how many projects? 50 projects. Yes, you heard me right. We have finished so far 50 projects on this channel, and we are going to do 20-25 more projects by the time we are done with doing these projects. So today we are going to do project number 51, which is about playing with encryption. Okay, while he is traveling to that place, let me explain what we are doing to do. Okay, so a law office is looking to explore the encryption features on AWS. A new engineer is investigating how to encrypt and decrypt customer case files and data in text file format. So what are we going to learn? We are going to learn how to encrypt and at the same time decrypt some text files. Okay, so he's taking forever to go. I think he was in a different island. This is Cloud Isle. Through Cloud Isle, he is going towards Security Isle. Not sure way how far that is. All right, here we are at Security Island, and let's see where the person who gives us the quest. Let's see, where are you? Okay, I don't see anybody. Maybe he will go this direction. Maybe that person or this person. Okay, this person looks like. All right, finally we are here. Hello, nice to meet you. I am the principal engineer in our law office. Thanks for dropping by. Nice to meet you too. How can I help you? Our office is currently using rooms full of paper files, which we are digitally migrating to cloud. I want a solution to encrypt the digital data. I am new to the cloud and I am trying to understand the encryption features on AWS. Can you give me some advice? Sure, I think AWS KMS can help. AWS KMS stands for AWS Key Management Service, which is a managed service that you can use to create and control the cryptographic keys that are used to protect your data. Is it safe? Who can access the keys? Yes, it is very safe. AWS KMS uses hardware security modules that have been validated under FIPS 140/-2. Your encryption keys are only used inside these devices and can never leave them unencrypted. You can also use AWS IAM, Identity and Access Management, policies in combination with key policies to control access to your KMS keys. Awesome, but how does it work? First, you want to create a symmetric encryption KMS key. Symmetric encryption keys are used in symmetric encryption, in which the same key is used for encryption and decryption. You can use the created KMS key in a few different ways. Can you tell me something about the data that you want to protect? We have two main types of data. Our customer case files can be quite big in size. We also have smaller sized data such as database passwords that need to be encrypted. All the data is in text format. I see. To encrypt your customer case files, I recommend using KMS keys to generate a data key to perform encryption operations. Data keys are symmetric keys you can use to encrypt a large amount of data. How about the smaller size data such as database passwords? For data less than 4 kilobytes, you can use KMS keys to encrypt and decrypt data directly without generating a data key. Sounds promising. I'm still trying to digest the information. Can you demonstrate the two ways to encrypt and decrypt data for us? Sure, why not? Great, I really appreciate your help. So let's look at what are the things that we are going to learn by doing this project. We learning creating a symmetric encryption AWS KMS key, generate data key to perform cryptographic operations. Then we will use AWS KMS key to perform cryptographic operations. All right, so let's click on start. Okay, here we are at the diagram. Let's look at the video concepts. As usual, check these videos before jumping into the actual project. The reason being, these will explain each service in detail. I am not going to play them here, but you can watch them on our playlist. Another playlist that we have, it's called AWS Tutorials for Beginners. The link for that will pop on the right side here. Click on it, go watch the videos with the same title, and come back and resume where you left it off. Okay, let's look at our diagram steps here. Once you watched videos, come and watch the remaining section here. This solution uses AWS KMS keys and data keys to encrypt and decrypt data. Okay, so here you can see AMS keys and data keys. Those two are two different things. We will learn about them in detail here. And AWS IAM policy is created to grant Amazon Elastic Compute Cloud or EC2 permissions to use and access KMS keys. This policy is attached to an IAM role. Okay, that is displayed here where you will have an IAM policy which is attached to an IAM role so that we can access the KMS key. And I mean, the IAM policy is in the IAM role and then IAM role is attached to this EC2 and then through EC2 we are going to access that key. And then when you launch an Amazon EC2 instance, you specify an IAM role to associated with this instance. KMS is a managed service that helps you create and control the cryptographic keys that are used to protect your data. You can use the AWS KMS API to create and manage KMS keys. The EC2 instance sends a KMS API request to create a symmetric encryption KMS key. For symmetric encryption, in which the same key is used for encryption and decryption, AWS KMS creates a symmetric encryption KMS key. The EC2 instance can also send a KMS API request to generate a data key. Data keys are symmetric keys you can use to encrypt data, including large amounts of data and other data encryption keys. AWS KMS returns a plain text data key for immediate use, which is optional, and a copy that is encrypted under a KMS key that you specify. So as you can see here, KMS key, algorithm plain text data key, and encrypted data key. You can use the plain text data key to encrypt data outside of KMS and store the encrypted data key with the encrypted data. For optimal security, we recommend that you immediately delete the plain text data key after encryption. I think which is what they are showing here. You have the plain text data key and the plain text data that you want to encrypt. Then you have the encryption algorithm. Then you have the ciphertext. And then they are asking you to delete this data key. To decrypt the data, you must first decrypt the encrypted data key to a plain text data key. So we have the encrypted data key, then we will use the KMS key and decryption algorithm, then you will get the plain text data key. And once you get the plain text data key, you will use that to decrypt your file. You can also use the KMS key to encrypt and decrypt data up to 4 kilobytes without the need to generate a data key. Cryptographic best practices discourage extensive reuse of encryption keys. AWS KMS supports automatic key rotation, which generates new cryptographic material for the KMS key every year. I think you can see that here. AWS KMS saves all previous versions of the cryptographic material in perpetuity, so you can decrypt any data encrypted with that KMS key. AWS KMS does not delete any rotated key material until you delete the KMS key. Using AWS KMS, you can replicate keys from one AWS region into another. With multi-region keys, you can move encrypted data between AWS regions without having to decrypt and re-encrypt with different keys in each region. So I think that's about the diagram steps. So let's go and look at the actual project here. So here we will have the practice lab goals as usual and DIY. So practice lab goals, what are we going to do? We are going to review an IAM role attached to an EC2 instance. So they already created the role. Probably they already have a policy attached to that role, and this role is attached to this EC2 machine. Then we are going to create a symmetric encryption key by using KMS. Then we will generate a data key and use it to encrypt and decrypt data. Then we are going to use an AWS KMS key to encrypt and decrypt data directly without the generation and use of a data key. Then using DIY, we are going to create a new multi-region KMS key that has symmetric encryption. Then we will enable automatic key rotation for the created multi-region KMS key. Alright, now let's go jump into the practice. And as we already know, in the practice session, AWS is going to give us each step by step how we have to do it. And in the DIY, they will leave it up to us. They won't help us do it. So looks like we don't have any files. Let's click on start lab. It might take some time, which is quick. Okay, so we are going to go to EC2, and another thing, each page has a concept to it, which is going to tell you about the service that we are going to use. I am not going to read this, but I want you to pause the video and read it. on each page. Okay, so we are going to go to the EC2 and then we'll click on the EC2 machine that is already running, then click on the security and then the IAM role that is attached to this EC2 machine, and then we are going to open the policy that is attached to it, which is instance basic role default policy, and we will go through the policy. As you can see, it has an action. What are the actions that are allowed under this policy? We can describe the EC2 instances, then KMS we have all the actions as part of it, then S3 get list put and resource all resources effect allow, and then we are going to go to the KMS. You can type it there, open it up, and then we are going to create a key, and then we are going to key what type of key? Symmetric key. Symmetric key, what did we learn about symmetric key? Symmetric is something that will use the same key to encrypt and decrypt. So for what purpose? Encryption and decryption. And then in advanced settings we are going to go for KMS, not external or any of this, and single region key. Multi-region key we are going to create as part of DIY. So for now it's single region key, and then we are going to name it my KMS key and then click next. And then key administrators, I think they already created a user which is lab user, so we are going to select that and then we'll select allow key administrator to delete this key. Click next. And by the way, I hope you are reading the concept on each page. And once you do that, select that, click next, and these are about key usage permissions, I guess. And once we do that, let's review it and then scroll down and then click finish, and then we have an AWS key successfully created that we can use. And once we have that, check the status enabled, then key rotation, which we are not going to, but I think they showed it so that we can use it in the DIY. Then we are going to go to our EC2 machine and then we are going to log into that EC2 machine so that we can use the key that we created to encrypt a file. Then we are going to use EC2 instance connect to it, and the username is EC2/user. And once we are in here, what we are doing is we are just echoing and writing it to a file called sample secret.txt. So let me copy paste this one so that I can use it in our exercise. Okay, and what is it? Okay, that, and once we do that, we can cat to display whatever is in that file. All right, once we do that, what are we going to do? We are going to use this particular command, generate data key. So the data key is going to be generated using the key that we created a minute ago. So what is the command that we are going to use? This one, let me copy that as well. So we are saying AWS KMS, that is a service. We are telling generate data key, and the key ID is that key that we created, and using that key we are going to create the data key, and we are saying key specs AES 256 encryption context project practice and the region we are giving. And once you do that, you are going to, I think, get this data key, and then we are going to run this particular command, which is okay, echo. Okay, because whatever key they are giving us, we need to convert that into base 64. I think that is explained here. To decode the encrypted data key and save it into a file named that we are going to do that. Okay, so actually I think it might have been in the base 64, so we are, I think, decoding it using this command. Once we decode it, we are echoing this one as well. So that is the plain text, echo plain text base decode to that one. Then we are again running echo this ciphertext blob, again writing okay, what are we trying to do here? Echo that and that to the same file. So we are, instead of doing it in one line, I think we are doing both and putting it in the same file. Okay, that's fine. I think it's the same command twice. Okay, which I guess I will remember to do that. So now we have our data key, and then I guess we are using this particular command to use OpenSSL and encrypt the file, that .txt we created in the beginning with the plain text data key, and save the output file. So we are going to use this particular command to encrypt it. Don't worry about it. When we do it, we will again go through these steps. Okay, so once you do that, if you more on this file that we encrypted, it is going to show you something like this, salted or whatever it is, which is something that we cannot read. The reason being it is encrypted. Previously, when we created a file, it has this is my secret text to encrypt. Now that is not what is showing, it is showing something else. Then let's click next. Okay, so now we encrypted it. Now we are going to decrypt it. Okay, so how are we going to decrypt it? We are going to first of all remove that uh, data key that we created earlier. So just remove it. What did we more on? We more on the encrypted file, right? Okay, yeah, not this one. Once we remove it, we are going to use again AWS KMS decrypt command, and looks like this command takes the cipher text blob, the data key encrypted.txt. By the way, but didn't we already delete that? Hmm. So, okay. And echo, we are going to do all this, but I don't understand something. Okay, let's see. To delete the plain text data key, run that. Okay, to obtain the plain text data key from its encrypted copy, run this. Okay, so we are going to get the plain text data key again, but here we are going to use the encrypted copy to get that key. And once we get that key, we are going to do the same thing again, echo, and then write it to in a different file. And are we going to do it twice for the key ID as well? No, this is just ID. So plain text, we are going to do that. Okay, got it. Yeah, I mean, this might look too much, but usually applications take care of it. We won't do it something like this manually anyways. And once we do that, now let's go ahead and decrypt it using again the OpenSSL command. And once we do that, we are going to get the output directly, which is this is my secret text to encrypt. Okay, and we are going to create another new file. I don't know why they are making us do that, but well, we will do what they tell us to do. Okay, new secret file encrypt without using a data key. So now whatever procedure we have done is using a data key. That's why we have to go through all those steps. Now we won't use data key. Instead, we will use the KMS to do all those steps for us. So I think it is very simple. Or we can again we are going to use the encrypt key, but this time we had few more additional parameters. Previously, we just I think left it till that project and then that, but right now we are going to combine both, creating that data key and as well as our output file encrypted in this one. Okay, so once we do that, cat that again, it is going to have show you that encrypted thing, so it won't show you much, which is similar to the previous one. Okay, nice. All right, now you can read through the concept. And once then we are going to use decrypt to decrypt it. Previously we encrypted it. using the encrypt command. Now we are going to use the decrypt command to decrypt it. Once we have the file, we can just cat it and we are going to get our decrypted text. So this is a little bit simple, right? We are not using that OpenSSL anymore to do that. Okay, that's it. Congratulations. Okay, so anyways, we have to do this again. I am going to do that. But what did we learn from this? What did we do? So there are two ways that we encrypted a file and decrypted a file. One is using the data key. One is, okay, what is going on here? One is using the data key and another is not using the data key. So when we use the data key, we have to get uh, plain uh, the plain text data key, and then we need to decode the base 64. And after we decode it, we used that decoded plain data key to encrypt it, and the same thing, we deleted that key after we encrypted, and then using the encrypted file we created the data key again, and then we converted that or decoded that into the plain text key, and then we used OpenSSL again to decrypt that file. So that is too much, I know, but using AWS KMS encrypt and decrypt, in one line we encrypted it and in one line we decrypted it. So that when it is doing the encryption, it is also taking care of creating that plain text data key and decoding. It is doing all that in a single step. Okay, do you guys remember what they showed us to do initially? They showed us to go to EC2, and on EC2 there is already an instance that is running. And click on this, and then they told us to go to the security and then the role. Okay, so once we go to the role, we need to click on this to see what are the things that are there under this one. This is the IAM policy that attached to the role, and that role is attached to our EC2 machine. As you can see, this particular policy gives the permission to describe the EC2 instances, and KMS everything we can do, and S3 will get a list to put all the resources and allow it. So which is not much. And then let's come back here, and we are going to go to the KMS, and let's create that KMS key. Create the key, and we're going to create a symmetric, and then encrypt and decrypt advanced settings. Key material origin is going to KMS, and it is going to be single region key. And what is the name that we are going to give it? My KMS key, and we don't have to give anything else. And they asked us to use lab user, I guess. Okay, isn't it the lab user that they told us to use key administrators? Yeah, this one. And then click next, and we are going to repeat the same thing again for the lab user. Click next. I think pretty much that's it. This will show you that policy that we just created. If you want to go through it, you can go through it and click finish. So now we have our data key. If we click on this, it should show the status enabled and the key administrators and all that, which is good. Okay, so once we do this, next thing is to log into our EC2 machine using the EC2 instance connect. So once we connected to it, the first step is to create a dummy file that has the text called "this is my secret text to encrypt." Once we do that, we are going to create or generate a data key, and in order to do that, we are going to use AWS KMS generate data key, and we are passing the key that we created. and the output of this will be this plain text and then the cipher text blob. Okay, so what we are going to do is we are going to use this information, the plain text and the cipher text blob, and if you we list, we will only have one sample secret file. You are going to use this to create our data key encrypted. Okay, remember, data key encrypted. By using these two, we are going to get what? Data key encrypted. But we are going to use the base 64 to decode it. So first of all, we'll copy this, paste it, and that, and then we are going to use this command called base that. Okay, and click enter. So again, what is this? This is data key encrypted.txt. And once we have that, we have to again use the base, the echo this and base 64, even this cipher text blob using the same command. Since this is a bigger text, I have to do it on my notepad first. So let me do that. Okay, which is what I did here. Let me paste. As you can see, echo, then the base, and we are going to put it in the same file again. Okay, so we are going to again put this in the data key encrypted file again. All right, so we have it here, and let me go back here and see it if you are doing it correctly or not. Both are going, oh, okay, never mind. The first one is going into data key plain text, the second one is going into data key encrypted. So let me correct that. I did a mistake here, so let me remove data key encrypted. So the first one is not going into data key encrypted because this is plain text, right? So it has to go into data key plain text, plain text.txt. Yes, and the second one is cipher text blob, so this is going to go into the encrypted, so which is this one. Okay, now we should have three files. One is our sample text file that we are going to encrypt, another one is plain text one, and another one data key encrypted. So far so good. Okay, now we are going to use this data key plain text to do what? To encrypt our file. And since we are going to encrypt without the KMS here, we are going to use the OpenSSL and we are going to say encrypt, and the algorithm is AES 256, and my input file is this, and output file, the encrypted file is going to be this one. And what am I using to encrypt this one? The data key plain text txt. So once I do that, I should have another file which should be the encrypted secret, and this should not show the text something like the previous one. Okay, oh, that's not what I wanted. Okay, this is similar to the uh, this one. Both are same, but this is unencrypted file, this is encrypted file. That's why we are not able to see any data. Good. So far so good. Okay, now we have this. Now we don't have any use with the data key plain text, so we are going to remove that, which is removed. Now once we remove it, in order to decrypt it, we are going to again create another plain text key. But how are we going to get that? Now we are going to use the data encrypted file that we have created previously and get the data key plain text from it, so that we are going to use that to decrypt it. So this time we are going to use the command from the AWS itself, AWS KMS again, and we are going to say encryption context is that cyber, it is that one, the data key encrypted region. So once you run it, it is going to give you the plain text. This time you don't see any ciphertext because we used that to get this one data key. Okay, so if you are wondering if this one and the previous one will be the same, no, it won't be the same. That's the point of deleting that and creating and generating a new one using this encrypted file. Now once we have this, we will repeat the same process again. We will decode, copy, paste, and then the whole base, and we will write it to again similar kind of file. Okay, now we again got the data key plain text this time, because in real time, once you encrypt something, you should be deleting the data key plain text. That's what they recommend. So you won't have access to it. So while decrypting, then how will you do it? You are going to share the encrypted data key with the client who will read, trying to read the data. So using that encrypted, they are going to get the data key plain text, and then they will use that to decrypt it. So again, just like encryption, we are going to decrypt using OpenSSL. You might be saying like we already decrypted. Why? Okay, no. Here we are decrypting the encrypted key. Here we are decrypting the file, and this is the input we are telling, and use the plain text, and we are not giving any output because it will directly print here. That's the point. As you can see now, it decrypted the encrypted file from something like that to our original input. Right, so successfully what did we do? I know these are a lot of steps, but basically what we did was we created a sample file which had this particular text. Then we used the AWS KMS generate data key, and we supplied our KMS key we created to get the details of the data key plain text as well as cipher text. And then we use the base64 to decode the data key plain text, and we put it in a file. At the same time, we um, got the cipher text and used the base64, and we decoded it into another file called encrypted secret. Then we went ahead and used the data key plain text and encrypted the file using OpenSSL. As soon as we encrypted it, we removed the data key plain text. Gone. Now assume we are in the client side. The client will be shared the encrypted secret, data key encrypted. So what we did, we used the AWS KMS decrypt command and supplied it with the encrypted data key, and then the output we got is the data key plain text, but we had to decode it using base64 and again wrote it to the similar file called data key plain text. Then we used this one and supplied it to OpenSSL to decrypt our encrypted file, and successfully we decrypted it to our I know it's a lot of stuff, but yeah, that's what we did. Now we are going to create a new file. That file will have the data new secret file. So we can see that by just looking at this one. Oops. Okay, I don't know. I want to just cat this. What is the file name? Oh, I think new file. Yeah. Oh, it doesn't have anything. Why? Okay. Oh, there was a echo before this. Never mind. Okay, if I cat this, I should get this data. New secret file encrypt without using a data key. Okay, now we are going to repeat the same process. We are going to do the same thing, but we are going to use AWS KMS to encrypt decrypt instead of OpenSSL. And this is going to be easy. We are going to use this command called encrypt, KMS encrypt, and we are going to pass our KMS key, and we are going to tell which file I want to encrypt, and we are going to tell the same things like output should be text, and cipher text blob, query it and pass it to that, and we are telling it to decode using the basics for all in one single command, and then we got our decrypted file right here. Encrypted file right here. New secrets. Okay, so as you can see, that above file got encrypted and we cannot read it. Now once we have it, all we have to do is use the decrypt command, and again we are telling it my ciphertext blob, and then we are telling it the file that is encrypted is this one, and output text, query, plain text, etc. And here if you see, we are not decoding anything manually. The plain data key, plain text key, encrypted data key, etc. all is done by the KMS using this command. So now I should have the decrypted one, as well. Here if I cat this one, this should show me the previous data, whatever was in my initial file, which is that one. It should look the same, right? Easy peasy, right? I know it's confusing, but well, that's KMS for you. Encryption and decryption, it's supposed to be that way. But anyways, we successfully finished the practice lab and we did both the steps. Now let's go ahead and do the DIY section. And in the DIY, we are going to create a new multi-region KMS key and we are going to enable automation key rotation for that. It's simple. We already saw where we can do that, and we are going to pay the new AWS KMS key ID. I don't think it is going to be tough because we know how to do this. Create the key and symmetric, that is going to be the same, and we are going to create a multi-region key. And what else did I discuss? Oh, automation as well. Okay, next. And we can name this multi-region key. Click next. And we are going to do the same thing, or I can just go here and pick that user. Next. Go here, user. Next. Oh no, where did I miss it? Where is it? That rotation we have to pick somewhere. Advanced options. No, we saw it somewhere, right? Where did we see it? Maybe after creating it? Okay, let me see. Okay, it's definitely not here. Okay, definitely not here. Finish it. Okay. Yeah, schedule. Oh, is that what they are asking? No. They asked us to automatic key rotation, not deletion. Cancel it. No, where did we miss it? Key rotation, view key actions. I saw it somewhere. Do you guys remember it? Yeah, here. Never mind. Key rotation, automatically rotate. Save. Now what did they ask? They asked us to go here and get the key ID, which is this one. Copy it, go it and paste it. And trust me, this validation actually works. If you enter the wrong one, it fails. Green, green, give me green. Yes, you did it. You created a new AWS KMS multi-region key and enabled key rotation. Now return to the city and give your customer the good news. Yay! Today I learned something new. Did you guys learn something new? If you did, then you know what to do. Go ahead and leave a comment. Yes, leave a comment. I want to hear your thoughts on this project. Amazing, your solution really helps protect our confidential files and data. Wonderful, you are very welcome. As a token of appreciation, choose a reward. I like this one. Yes, please go ahead and hit that like and comment it. We are not done yet. In the comments, do tell me whether you like this or not. If you already know how to decrypt encrypt, let me know that as well. Fireworks, and it is time for feedback. Go ahead. If you haven't subscribed, this is a good time to do that. And leave a comment, like, etc. so that I want this playlist to be visible to pretty much everyone who is searching for AWS real-time projects, because these are awesome projects that there is not enough visibility. That's how these are not getting to other people, and you have it in your hands to take this to the internet. Okay, so do share it with other people, and by commenting and liking, YouTube actually shows this in the results for other people as well, so that they can check this out. Okay, now what are we going to do? We are going to zap some drones. So this is our quiz time to test whatever we learned so far in this project. So let's go ahead and let's try to answer these questions. Which AWS service integrates with AWS KMS to provide logs of all key usage, helping users meet their regulatory and compliance needs? I think that has to do with the CloudTrail. The only reason I'm picking that is because the compliance and that. I might be wrong, but let's see. And I am right. Oh, lucky me. Okay, let's see. Okay, we have one more here. AWS KMS generates, stores, manages, and tracks data keys. KMS also performs cryptographic graphic operations with data keys. Hmm, sure. No, I think it doesn't perform with the data keys. Oh my goodness. Which computing devices validated under the program does AWS KMS use to generate and protect keys? I think it has to do with security key modules, or is it hardware security modules? I think it is this. Let me look at the hint. Yeah, it's HSM. They shorted it, but I think it is this one. And yes, I am correct. I should have checked the previous one, but it's okay. So we don't have any more here. Let's click on that one. AWS services that are integrated with KMS use only symmetric encryption keys to encrypt data. I think it is false. We can use asymmetric as well. Yeah, most commonly used, but we have asymmetric as well. What? Okay. What do users need to create if they want to own and manage hardware security modules provided by Cloud Cluster? This one, I guess, I don't know. I seriously don't know what this is. Custom key stores. Oh yeah, a customer no. Custom key store. Okay, cool. Yeah, I don't know much about this. I'm not security. Usually there will be a separate team taking care of it. Which statement about the automatic key rotation for KMS is true? When key rotation is enabled, KMS generates new cryptographic material for the KMS key every 2 years. No, it does every year, right? That's what we learned. See, that's why. Oh, come on. I think I need to check all this. What is the best practice after an application has encrypted data with an AWS KMS plain text data key? To delete it, we have to remove it. Remove. Only we remove the plain text, not the encrypted data. Yes, this will be the correct one. Yes, I know. Yeah. Which protocol do AWS services use when encrypting data in motion to provide encryption between an application and the service? I think it is TLS, right? It is TS. Yeah, it is TLS. Yes, it is TLS, transport layer. Yes. Okay, not bad. So far, I think we did what? 50-50? Or we did 4 correct, 3 wrong. What is the data size limit for using KMS key? What did they say? I think 4 KB. Let me cross check it because yes, 4 KB. All right. In AWS KMS, a symmetric encryption key represents a 256-bit encryption key that never leaves KMS unencrypted. I don't know, to be honest. Hmm, not sure. Encrypt, decrypt, and re-encrypt data. It can also generate data keys that you can use outside of AWS KMS. What do you guys think? That never leaves KMS? No, actually it does leave, I guess. No, that is wrong. My true is the right one. No. Yeah, I think we are done with the KMS questions, and I think I most probably did 50-50. Give me some slack, guys, because I'm not that good at security. Okay, I guess I think that's it for today. I don't think I'm doing any architecture related question. I'm not going to zap that, but I hope you enjoyed this. As always, I'm not the smartest guy in the class. If I don't prepare that well, I won't know anything. So security is something that is not my forte. This is the first time I'm doing actually uh, the projects here, so I am learning along with you guys. I hope you understand that. And if you enjoyed this, you know what to do. Go ahead and leave a comment and do the like the video. And thank you very much for your time. Have a great day. See you in the next one. Peace out.